Empirical rule. For any quantitative data set with roughly a bell-shaped distribution, the following properties hold. Property 1. Approximately 68% of the observations lie within one standard deviation to either side of the mean. That is, between x bar minus s and x bar plus s. Property 2. Approximately 95% of the observations lie within two standard deviations to either side of the mean. That is, between x bar minus 2s and x bar plus 2s. Property 3. Approximately 99.7% of the observations lie within three standard deviations to either side of the mean. That is, between x bar minus 3s and x bar plus 3s. Picture of the empirical rule. About 68% of the observations lie between one standard deviation. About 95% of the observations lie within two standard deviations of the mean. And about 99.7% of the observations lie within three standard deviations of the mean. At this point, the line gets very close to our number line. Even though it never crosses it, we don't have a significant amount of observations more than three standard deviations away from the mean. Example: construct the graph using the empirical rule. A placement exam for entrance into a math class yields a mean of 80 and a standard deviation of 10. The distribution of the 120 scores is roughly bell-shaped. So what we know at this point is that our mean is equal to 80 and our standard deviation is equal to 10. Looking at our graph of the empirical rule, 68% of our data lies between one standard deviation of the mean. If our mean is 80, then 80 plus 10 would give us 90, and 80 minus 10 gives us 70. 95% of our data lies within two standard deviations of our mean. This means that 80 plus 2 times 10, or 90 plus 10, will give us 100. And 80 minus 2 times 10, or 70 minus 10, will give us 60. Next, we are told by the empirical rule that 99.7% of our data lies within three standard deviations of the mean. So we can either find 80 plus 3 times 10, or simply 100 plus 10, which is 110, or 80 minus 3 times 10, or 60 minus 10, which gives us 50. What this means is 68% of our data lies between 70 and 90, 95% of our data lie between 60 and 100, 99.7% of our data lie between 50 and 110. Example: apply property 1 of the empirical rule to make pertinent statements about the observations in the sample. So we have our empirical rule with our 68, 95, 99.7%. From the previous information, we have that our mean is 80, our standard deviation is 10, our sample size is 120. One standard deviation is between 70 and 90. 2 are between 60 and 100. 3 are between 50 and 110. If it helps, we can write this on our graph. So we have 50, 60, 70, our mean is 80, 90, 100, 110. Property 1 tells us that 68% of the observations lie within one standard deviation. We know that our sample size is 120. 68% times 120 gives us 81.6, which we'll round to the nearest person, which is 82. At least 82 out of the 120 people sample scored between 70 and 90 on the placement exam for entrance into a math class. Example, apply property 2 of the empirical rule to make pertinent statements about the observation in the sample. So we've carried over the information. We know that 95% of the data lie between 2 standard deviations of the mean, according to property 2. 95% times 120 gives us 114. At least 114 out of the 120 people sample scored between 60 and 100 on the placement exam for entrance into a math class. Example, apply property 3 of the empirical rule to make pertinent statements about the observations in the sample. Property 3 tells us that 99.7% of the sample lie within 3 standard deviations of the mean. Since our sample size is 120, we have 99.7% or 0.997 times 120, which gives us 119.64, which rounds to 120. At least 120 out of 120 people sampled scored between 50 and 110 on the placement exam for entrance into a math class. To recap the section, empirical rule. The empirical rule tells us that 68% of our data lie within 1 standard deviation of the mean. 95% of the data lie within 2 standard deviations of the mean, and 99.7% of the data lie within 3 standard deviations of the mean.